Hi, everyone. Thanks so much for coming. My name is Virginia Heinen. I'm a postdoc at the University of Nevada, Reno with Dr. Vladimir Pravosudov, and I'm going to talk about dominance and cognition in mountain chickadees. So the motivation behind this talk and this experiment is that dominant individuals often show better cognitive performance, and this is often on spatial cognitive tasks. So this phenomenon has been observed in many taxa, such as tree shrews, pheasants, lots of different animals. And one of the drivers behind this is hypothesized to be that the stress associated with social subordinates impairs cognitive ability. In fact, in my study system, the mountain chickadee, previous studies have found that subordinate birds have worse spatial memory, and they also have a reduced hippocampal neurogenesis, which may be the mechanism behind this. However, lab experiments like this are conducted in small areas, and the dominance interactions are often dyadic, only two birds present at a time. And in natural environments, in contrast, birds have many more social partners, and they have a lot more spatial freedom. They don't have to spend time in close quarters with a dominant partner. So we wanted to see if this relationship persists in the wild where groups are naturally occurring and consist of multiple individuals. So what is the relationship between social rank and spatial cognition in wild groups? So our study system is a group of pit-tagged mountain chickadees at the Sage Hen Experimental Forest in California. So this is a long-term study system. These birds cache tens of thousands of food items and then retrieve them throughout the winter. So spatial memory and spatial cognition is very important to their survival. And mountain chickadees also have linear dominance hierarchies within their flocks. And if you've heard any talks by our lab group, you'll also know that we study these birds at two locations. We have a high elevation site, which has much harsher winters and fewer available food sources, and a low elevation site with a lower ambient temperature and more food sources available. So the first part of this study was to determine the dominance hierarchies in these wild birds. So we set out these single RFID equipped feeders. You can see that gray box in the middle of this picture. And these feeders record all visits from banded birds that visit, records the time, the duration, and the identity of the visit. Then, using a technique developed by Julian Evans, we extracted displacement events from this feeder data. So a displacement event is when one bird shows up to the feeder and physically evicts a bird that's already there. And so this is considered a dominance interaction where the displaced bird is the loser and the displacing bird is the winner. And then we used these displacements to calculate David scores and infer dominance hierarchies within flocks. The second thing we did was determine these birds' cognitive abilities using these arrays of 8 feeders. So you can see one in the middle here. Here's a schematic of it. Basically, we have 8 feeders arranged on this square, and we can program these feeders so that only one feeder out of the 8 will provide food for a given bird. If that bird shows up at any other feeder, it doesn't get a reward. So the first test is the spatial learning and memory test, where the bird simply has to learn and remember which feeder out of the 8 provides food. So it has to learn the location of this rewarding feeder. We ran this test for 4 days. Then we conducted the second test, a reversal learning test, where we no longer reward this feeder, and instead the bird has a new rewarding feeder. So this bird has to learn and remember the location of this new rewarding feeder, as well as learn that the previously rewarded feeder is no longer going to provide food. So this is a test of cognitive and behavioral flexibility. So I'm going to present here data collected over 2 winter seasons and testing over 200 individual birds. So first, I'm going to show the results from the spatial learning and memory task. I'm going to orient you to these graphs. So on the x-axis, we'll see the scaled dominance rank, where Lower scores indicate less dominant birds, and higher scores on the right indicate more dominant birds. On the y-axis, cognitive performance is indicated as the mean number of errors. So the birds with the worst cognitive performance have higher scores, and the birds with better cognitive performance have lower scores. So for the spatial learning and memory task, we found no relationship with dominance at either elevation in 2019 or in the 2020-2021 season. So just completely flat there. Looking at the reversal learning task, we again saw no relationship between rank and reversal spatial cognition in the 2019-2020 season, but we did find a significant rank by elevation interaction during the rank by elevation interaction during the 2020-21 season, although you can probably see from this graph that it's a fairly small effect size. So we wanted to dig into this interaction a little more and see what was going on. So now I'm going to zoom in on the data from 2020-21, and beyond that, I'm going to zoom in on performance over the first 20 trials of this learning task. So on the x-axis, we essentially have time as we move from left to right. Birds are getting more experience with this task. And again, on the y, we have number of errors. So better performance is indicated by a fewer number of errors. And I'm also going to show the birds split up into quartiles based on their social rank. So we just group them based on the highest quarter, the middle quarters, and the lowest quarter. So at high elevation, we found a significant relationship between rank and cognitive performance during the first 3 and the first 5 trials. So I'd like to highlight that we've got much worse performance in the least dominant birds, those bottom quarter, those most subordinate birds. And we have a much better performance, much better reversal learning ability in the most dominant birds. And again, this is for the first 3 and the first 5 trials of the task. So after that, performance gets more and more similar across ranks. And at low elevation, we found absolutely no relationship between performance and rank. So to wrap things up, we found no relationship between dominance, rank, and spatial learning and memory in this wild system, which is, thank you, which is quite different from what we found in the previous lab studies. We did find a relationship where dominance was associated with better reversal spatial learning and flexibility, but only in 1 year and only at high elevation. We're still not entirely sure what this is, but we believe it might be because this was the harshest year and high elevation is the most environmentally harsh conditions. So this may have been the most stressful environment out of all of the situations we tested. So as Kay alluded to yesterday, dominance was not solved in the 80s. And impressively, our lab results and field results in this system were very different. So this highlights that it may be important to test these assumptions from lab studies in wild populations in larger social groups and see how things translate. So